Section 4.3, Hess's law, is based on enthalpy being a state function. So how do we determine the enthalpy of formation for gaseous ethane at the room temperature? Plan A. We can start with pure elements in the standard state at the room temperature. So we just need to have carbon react with hydrogen at the room temperature, make sure both are in the standard state, and then we can make ethane. And then we measure the heat of the reaction. The enthalpy of the reaction is equal to the heat of the reaction under constant pressure condition. And therefore, the enthalpy of formation of ethane is simply the enthalpy of reaction is equal to heat of the reaction. Well, can you make carbon react with hydrogen at 298 K under the standard state condition and produce ethane and ethane only? It's impossible. So we have to be smart. We have to know that enthalpy is a state function, so we don't have to do a one-step process. We're going to do three-step process to produce ethane. And actually, we are not even producing ethane. We're going to use ethane to react with oxygen to produce CO2 and H2O. In this case, ethane is on the left-hand side. But also, we can also combust carbon and hydrogen so that by combining these three reactions, we will be able to get the enthalpy of formation for ethane. So if you look at the three reactions, 2 times reaction 2 plus 3 times reaction 3 minus 1 times reaction 1, well, that will put this ethane on the right-hand side with the negative sign. And then we get this target reaction. We start from carbon, hydrogen, we end up with ethane. And then if we need to know the enthalpy of formation of C2H6, it's very simple. Well, it's going to be just 2 times the enthalpy of reaction of this reaction 2 plus 3 times this reaction minus 1 times this reaction. That's it. Again, enthalpy is a state function, so we can design this 3-reaction process or 3-step process to get the enthalpy of formation indirectly. How do we calculate the average bond enthalpy of the OH bonds in water? Well, we need to know the enthalpy of formation of the hydrogen atom, oxygen atom, and the enthalpy of formation of water in the gas phase. The reason is we need to get rid of the hydrogen bonding effect over here. That's between water molecules. And this question, the bond enthalpy of the 2 OH bonds, well, that's within a single water molecule. How do we do that? Again, very simple. The difference between a water molecule and 2 separate hydrogen atoms plus 1 oxygen atom is the 2 hydrogen bonds. So we can do this to get the enthalpy of these 2 OH bonds. And then divided by 2, we get the bond enthalpy of a single OH bond. When you do this, the number is negative. Actually, the bond energy is sometimes negative, sometimes positive. But you just need to remember, when a chemical bond is formed, energy is released, enthalpy decreases.